Okay, for our 2.5 comparing proportional relationships notes and examples, I'm going to break it into 3 different videos because there are 3 different examples. And I just think one long video would be pretty much boring for everybody, and it's going to be easier to break it apart. And you can look back at the example that you need to if you need to go back and learn some more stuff. You don't have to worry about going through one big video. So we actually did some of this with our problem we did the other day, where we had to figure out when the boy's phone battery was going to die, and we had to make predictions, and then we figured out the time that it actually did die. And we set up a proportion, if you remember that. We set up what's called a proportion, meaning we took the 2 pieces of information we knew, which was the percentage and how fast it was dying or decreasing, and we set up a proportion to figure out how fast it was decreasing over the whole period of time. So that's what we're going to be talking about today, as proportions. When things are happening in a consistent manner, or in other words, the same. So increasing or decreasing by the same amount. All right, so let's look at example 1. The first one is we're going to be looking at tables and graphs. So as you can see over to the left, we have a table about this one airplane, and then we have a graph about a different airplane. So we're going to look at tables and graphs on example 1. It says, Mira is researching cruising speeds of different planes. Which airplane has a greater cruising speed? So we want to figure out which one is moving faster, pretty much is what it's saying. So a greater cruising speed. Okay, so the first thing is, so the the information's up top. Okay, let me figure out my tech for a second. There we go. It's going to take us down here to step 1. So this is where we'll do our work. So the first thing we're going to compare is the airplane that's called the Cessna. And that's given to us on a table. So if you notice, it's showing us the distance in kilometers on the top and the time in minutes on the bottom. So notice that the time isn't staying consistent. It starts at 5 minutes, and then it shows us 10 minutes later, and then it shows us 15 minutes later, and then another 15 minutes later, and it just keeps increasing in time. So it's not like it showed us every 5 minutes or something like that. So our goal is to figure out what is the actual cruising speed for every minute. Keep that in mind with what we're going to be doing with pretty much all of these. We want to find the individual thing that's happening. So every minute, every dollar, every person, whatever it is, every mile, whatever it might be that's happening, we want the individual piece. So our goal is to figure out how fast it is happening every minute. So what we're going to do is we're going to set up a really simple fraction. It's kind of already done for you without even realizing it, but it's going to be the distance over the time. So you're comparing or setting up a proportion showing the distance and the time. So let's look at the first one. So that would be 40 over 5. Well, that turns into 8. 40 divided by 5 gives you 8. Let's try it again. I'm going to not do that second one just for sake of space. Let's go ahead and look at this one, where it would, the third one, where it's 240 over 30. So what's 240 divided by 30? That also gives you 8. Let's try it one more time with this last one. Again, you could do this with all of these. I just skipped so that it didn't get too squished on the screen and too messy. So that last one, 480 over 60, that also turns into 8. So notice that it's consistent every single time. When we do that division, no matter what those numbers were, that means the speed stayed consistent, and the speed had something to do with 8. So now we just need to go back, and I should make a note that our goal is to find what's called the constant, which is what we did here, the constant thing that keeps happening. And so what we just discovered is that every 8, and the distance is kilometers, so every 8 kilometers, that's how far it travels every minute. So 8 kilometers per minute. That's called the constant. Now again, that's not our answer. We are trying to figure out which one has a greater cruising speed. So we've only looked at one, so there's nothing to compare it to. So now we're going to look at the graph. The graph over to the right is showing the Boeing 747. So again, we're going to end up comparing these two. So there's actually a note already there for you. It says, find the difference between any two pairs of coordinates. Remember, coordinates are just the points on a graph, so the locations. So find the difference between any two pairs of coordinates to determine the constant of proportionality. In other words, if you want to just think of it as the constant, you can't. So the thing that's staying consistent. So, and they actually, again, already have some of this done for you. So what you're going to do, notice that on our graph, the 2 points that they picked out, one location is 4,60 and the other one is 6,90. So what we're going to do with those two pieces of information is we're going to subtract and divide. The subtraction's actually already been done for you, but I want you to see it because we'll talk about it in a later example. So notice, if you recall on a coordinate, coordinates are always labeled x, comma, y. So 6,90, x, comma, y. So what happens here is you subtract your y values and look at your graph. The y-axis is the distance, which is what we just did. Remember, it was distance over time in the other on the table. So distance and then over the time that went by, the x value. Remember, the x-axis is the one on the bottom that goes from left to right. It's horizontal. So let's look at that again. They gave us two coordinates. So if we take the distance in between, so 90 minus 60, that's where this 30 is coming from. And then if you take the x values, which is 6 minus 4, that's where the 2 is coming from. So let's set that up the same way that we did for the table. So that would mean, again, distance over time would be 30 over 2, which when you divide 30 divided by 2, you get 15. So what we just figured out is that for the Boeing airplane, every 15 kilometers, or sorry, every minute it goes 15 kilometers. I always say that backwards. So to answer the question that was being asked of us at the beginning, which airplane has a greater cruising speed? Well, one of them is going 8 kilometers per minute and the other one is 15 kilometers per minute. So I'm hoping it's pretty obvious that the Boeing has a greater constant speed. Another way to think about constant speed, you may or may not have experienced this, or maybe your parents have shown you or talked to you about it, cruise control in a car. It's one of my favorite things with a car, honestly. What you do is you set the speed that you want to go, and your car will stay consistently on that speed. So that would be, now I will say here, especially in West Virginia, that depends on if you're going up or down a hill. Sometimes it'll slow down a little or even speed up if you're going down a hill. But overall, that's a constant speed. So that the Boeing in this case would be the one that is going faster. Okay, so let's talk about the try it problem, and then that'll be the end of this video. So here's the try it problem. It says the graph represents the rate which Marlowe makes origami birds for a craft fair. So he's making crafts. The equation y equals 2.5x represents the number of birds y, which is our y-axis, Josh makes in x minutes. So we don't know how many minutes it takes. Who makes birds at a faster rate? So we're talking about two people here. We have Marlowe. Marlowe is our graph over to the right. And then they gave us an equation for Josh. So we need to figure out what that means. So let's talk about Josh first. Let's try and decide. So Josh is our equation. So again, y, look, and you can use the graph to help you compare, y-axis is the number of birds. 2.5x, we've done a lot of word problems like this. That means, so let's write that, 2.5x means for every 2.5 minutes, for every bird that he makes. Again, these are crafts. So 2.5x from the equation means that it takes him 2.5 minutes for every bird. The reason we're using x is because we don't know how many birds he ends up making. So, but that's the speed, so that's the rate that Josh goes. Okay, so now we need to look at Marlowe, and his is over on the graph. So here's what we know about Marlowe. Look at over at where it says 20. 20 minutes, that's our x-axis. So right here. So for every 20 minutes, follow it up, he makes 4 birds. So we're going to set up a proportion like we just practiced. So I'm going to write that up kind of above the graph. So every 20 minutes, he makes 4 birds. Here's another thing that I didn't mention with the last graph is when you have a straight line, as we do in this graph and the one we had above, it was a completely straight line. That's how you know something is consistent or has a constant thing happening. Because if your line is going up and then down, or even just the slightest bit not straight, that means something has changed in the situation. So for example, like if we would have seen the line kind of going up and down on the airplane one we just talked about, that would mean the speed would be changing, which we know in reality that does happen. It has to speed up at the beginning and slow down when you're ready to arrive at your destination. So but the part that we're looking at on these graphs are specifically the straight lines, meaning something is consistent. Okay, so 20 minutes for every 4 birds. That reduces or divides to meaning every 5 minutes he makes 1 bird. Again, how I got that, all I did was divide. 20 divided by 4. So that's what we know about Marlowe. It takes him 5 minutes to make 1 bird. So who makes the birds faster? That would be Josh. So Josh makes his birds faster. Just like that. Okay, so those are proportions. And again, that was example 1.